There are three main variation formulas. There's directly, inversely, and jointly. To find a variation model, you need to 1. Write a general variation model that relates the variables given in the problem, and then you need to let k represent the constant of variation. Second, solve for k by substituting the known values of the variable into the model from step 1. And then 3, substitute the value of k into the original variation model from step 1. So, direct variation. Let k be a non-zero constant real number. We can say that y varies directly as x, or we could say that y is directly proportional to x. Either way it's said, it comes out as y equals kx. So the variable z varies directly as w. So z is going to equal kw. So that's what it would look like. Now I have w being 16 and z being 56, so I can plug it in and solve for k. So z is 56, k is unknown, and w is 16. Solving for k, divide both sides by 16, cancels out, and my constant value k is going to end up being 7/2 after it's reduced. So what is my variation model for this? It's going to be the exact same thing, except I'm going to replace k with 7/2. So my formula, z equals 7/2 w. And that's what models this situation. So now I'm going to take my directly varies model, and I'm going to solve for this part. Find the value of z when w is 84. So z equals 7/2, and w is 84, so times 84. And when you do the arithmetic, 7/2 times 84 is going to give you 294. So there's a solution to this part. Inverse variation. Again, let k be a non-zero constant real number, and we can say that y varies inversely as x, or y is inversely proportional to x. So an inverse variation formula is going to be y equals k over x. So b is inversely proportional to c, so I can say that b is equal to k over c. And now I'm going to let b equal 4 and c equal 3, and I'm going to find out what the model is for this variation question. So 4 equals k over 3. I'm going to multiply the 3 over here, and I'm going to get 12 equals k. So what does my model look like for this situation? I can say that y equals 12 over c. Actually, it should be b, not y. Excuse me. b equals 12 over c. And now I'm going to find the value of b when c is 2. So b equals 12 over 2. b is going to equal 6. So there's a solution to this part. Last, joint variation. Again, let k be a non-zero constant real number, and we can say that y varies jointly as w and z, or y is jointly proportional to w and z. Either way, it comes out as y equals k times w times z. So L varies jointly as a and the square root of b, so a little bit of a different flair for this one. So L equals k a, but square root of b is just going to be times the square root of b. And L is 72, a is 8, and b is 9. So I can just plug those in. So I'm going to get 72 equals k times a, which is 8, times square root of 9. And just going to do the arithmetic here. So 72 equals k times 8 times 3. 72 equals 24k. And then divide the 24 over. And I'm going to get 3 equals k. So the correct model for this situation is L equals 3a square root of b. And now I'm going to find the value of L when a is a half and b is 36. So I'm just going to rewrite it down here. So L equals 3a square root of b. And just plug in what my a and b are. Solve for L. So L equals 3 times a half times, don't really need the parentheses there, square root of 36. So L equals 3 times a half times 6. And then 3 times a half times 6 is going to give you 9. So the solution to this part here is 9.